ENGMA introduces itself as an AI-augmented governance and decision-making layer designed to enhance coordination, transparency, and operational efficiency within decentralized systems. The project's core vision is to integrate artificial intelligence into the workflows of DAOs, digital organizations, and protocol-level governance structures, offering a suite of tools that enable structured evaluation, automated reasoning, and more consistent decision processes. Rather than working as a standalone protocol, ENGMA aims to serve as a modular intelligence layer that developers and ecosystems can integrate into their governance stacks, allowing AI-supported logic to complement human voting and strategic planning. Public materials describe ENGMA as being built around composable governance modules. These may include analytical components, decision tree logic, AI-supported evaluations, workflow automation triggers, and systems intended to guide decentralized groups toward more data-driven decision outcomes. The goal is not to replace human oversight but to support complex governance choices with structured reasoning and automated execution where appropriate. In theory, this could enable DAOs to manage proposals more rapidly, analyze outcomes more consistently, and maintain stronger operational continuity even with fluctuating participant engagement. The ENGMA token is positioned as a utility element within this framework, although detailed tokenomics are not yet publicly available. Based on the project's conceptual materials, the token may provide access to deeper platform features, advanced AI modules, or governance rights surrounding system evolution. These elements remain high-level, and potential users should note that no independently verified documentation on token distribution, supply management, or economic incentives has been released. As a result, assessments of long-term sustainability must be based on the project's conceptual outline rather than measurable economic structure. Technically, ENGMA presents itself as a system capable of integrating on-chain and off-chain data sources into decision frameworks. However, much of its described architecture remains conceptual. There is currently no comprehensive technical documentation detailing how AI models operate, how their outputs are validated, or how potential risks, such as algorithmic bias or incorrect reasoning, are mitigated. Nor are public audits or detailed descriptions of logic execution pipelines available. This lack of technical clarity is not uncommon for early AI-driven governance initiatives, as building transparent, verifiable AI decision systems remains a major challenge across the Web3 landscape. The appeal of ENGMA lies in the broader context of AI-supported governance. As decentralized organizations have grown, so have the difficulties associated with managing complex proposals, executing logic across systems, and maintaining active participation. An intelligence layer capable of synthesizing information, evaluating alternatives, and triggering compliant actions could theoretically provide meaningful value. Yet such systems must be implemented with rigorous safeguards. Without strong transparency, verifiable decision processes, and community trust, AI-augmented governance tools risk creating additional uncertainties rather than resolving existing ones. ENGMA's narrative emphasizes modularity, suggesting that ecosystems may adopt the specific components they need rather than replacing the governance structures wholesale. This could allow gradual integration, enabling communities to test automated processes on a limited scale before expanding their use of AI-supported tools. The extent to which this modular approach succeeds will depend on the quality of integration, the clarity of documentation, and the consistency of technical delivery over time. It will also require effective communication to stakeholders about how AI recommendations are formed and how final authority remains distributed among human participants. At this stage, ENGMA stands at a conceptual inflection point. It offers an ambitious vision of AI-enhanced decision-making, yet many of the critical elements, technical transparency, model explanations, security audits, and practical demonstrations, remain forthcoming. As with many early-phase projects in the AI governance category, ENGMA's future will hinge on its ability to transform theoretical frameworks into operational modules that provide measurable improvements for decentralized systems. The project must demonstrate that its AI logic can be applied reliably, safely, and with sufficient oversight to maintain trust among the communities it aims to support. ENGMA presents a promising narrative for the future of AI-augmented governance in Web3, but its long-term trajectory depends on execution, transparency, and the careful balancing of automation with human decision rights. As development continues, its ability to deliver verifiable, functional governance modules will determine whether ENGMA becomes a foundational intelligence layer or remains primarily a conceptual exploration of AI-supported coordination. For more insights on ENGMA, AI-augmented governance systems, and modular intelligence layers for decentralized ecosystems, remember to like, subscribe, and keep learning, here at Crypto in Black and White.